Today we will discuss about time series forecasting models. First of all, we will understand what is time series data. A time series data is a series of data points indexed with respect to time. That means you will have a set of values against the time. It can be days or year or minutes or seconds also. Okay, that means here time is a independent variable. Okay, generally this time series data, it is a sequence. It is taken at regular intervals of time. So you will have equal intervals of time on the x-axis. You can take stock prices, which varies over different days, time period. It can be days or months or years also. So why we need to study means because of its application. Why we need to study that time series data means we can find different applications like statistics, signal processing, pattern recognition, econometrics, mathematical finance, weather forecasting, earthquake prediction, control engineering, communication engineering. I will tell one simple example, weather forecasting. So always the temperature of next days or future, it depends mostly on the previous days. Okay, so generally the temperature will move gradually. So therefore you can predict the temperature based on the past values. So you need to understand that the temperature data is a time varying with respect to date. Okay, with respect to days. And coming to definitions, we need to understand the difference between analysis and forecasting. So time series analysis means you will study about the methods for analyzing the time series data to extract statistics. For calculating the statistics, we will perform time series analysis methods. Okay, whereas when we will use forecasting methods means if you want to predict a future values based on the past observable values, then we will go for forecasting. Mostly for forecasting, we will take a model and we will train it and we will test it. Okay, so we will see some of the different forecasting, simple forecasting methods. First one is a naive approach. So what is naive approach means? So I will explain with a simple example. You take the price of a coin and on the y-axis, and in the x-axis the time unit is taken as days. So you can see the price of that coin fluctuates over different period of time. It is one form of time series data. In naive approach, the price can be predicted with the help of past values. That means past immediate values. If you want to predict the price at t plus 1, which is same as y of t. So that means the predicted value is same as the past value at time instant t. Okay, so this is a naive approach. That means you want to predict the temperature of tomorrow's temperature means. So in naive approach, we will tell the same temperature as today. That means if the temperature today is 35 degrees, tomorrow temperature also we will call it as a 35C. So it is meaningless, but this is also one form of approach, naive approach. And next technique is simple average. Again we will take one simple example. You can see this example. Here y-axis represents the price of the coin, x-axis represents the time in day units, and you can see the predicted output. It depends upon the average of past values, average of past input values. Here you can see the price value fluctuates over from 1 to 9 days. So what you have to do means you take all the values from 1 to 9 and sum it up and divide by 10. So that means the predicted value is simply calculated as average of previously observed data values. That is simple average technique. Coming to moving average, in moving average, sometimes why we are going for moving average means sometimes the price will fluctuate over differently for different periods of time. Say for example, for 1 to 3rd day, for first 3 days, it is slowly increasing. From 3 to 3rd day to 4th day, it is rapidly increasing, steeply increasing. From 4 to 6 or 7, it is somewhat steady, nearly steady. From 7th day onwards, it is again decreasing. So over different period of time, the trend is changing. So here the trend is increasing, rapid increasing, and this is slow increasing, and this is constant. Here, so different period of time we are having different trends. We will call it this as a trend. This is trend. So in such a case, if you perform the average over all the positive, over all the samples, it will give you the wrong prediction. So, okay, if you take the average of all values over different time periods, then it will give you the wrong answer. Why? Because here the trend is different, here again the trend is different, again here the trend is different, here again the trend is different. So, if you are predicting in this region, you take the trend of these samples only, not over other time periods. So, why? Because each time period trend is different. Okay, so that is the logic behind. In moving average, what we will do means we will take a window for the trend. Okay, from 7 onwards the trend is decreasing. So from 7 onwards we will take the average. Okay, this is what we are doing. We are constructing the sliding window. We will construct the window from day 7th day onwards. We will construct the window, and then we will perform the average over that window only, over the trend period only. So that is what is happening here. So over that time period, we will calculate the average, which is calculated as 1 by p, y of I1, y I minus 1 plus y I minus 2, y I minus 3 plus y I minus p. Okay. So here p represents the trend number of trend values. Okay. So that is a specialty. Instead of calculating the average over all trends, we will take only on that particular trend. Current trend only we have to take. Okay. So that is the thing. Okay. Here the trend is, that is the difference. If you want to calculate the price, predict the price of the petrol means, you should not take the trend during corona period. That will be meaningless. During corona period, the trend, petrol price trend is very, very less. So in fact it is decreasing. You cannot take that into account for calculating the predicted values. The corona period is exceptional trend, abnormal trend. You cannot take that into account. So you have to take the window of values. Okay, that is a specialty. And finally, weighted moving average method. So if you see in that trend, you can give some weights to some data, more weights to some price values, less weight to some weight values. You can modify that. In such a case, we will call it as a weighted moving average method. So weighted moving average method means you will perform the weighted average of that window. Within that sliding window, you will calculate, you will assign different windows. In the previous thing, we have assumed all equal weightage to all the samples in that window. You can see in this window, we have given equal weightage to all the samples. In weighted average, we will give different weights. Okay, depending upon its priority or importance, we will give different weights. And correspondingly, we will perform the average, weighted average. So here m is summation of all weights. And finally, we will discuss about simple exponential smoothing method. Here the weights are calculated manually. Instead of this, you can do the weights can be decreased exponentially also. So that means more weight will be given to recent values, and as you take lagged values, more past values, it will decrease, the weight will be decreased more. So that decrement in weight is proportional to exponential function. So alpha into 1 minus alpha into y of t minus 1, that means the weight for y t minus 1 is alpha into 1 minus alpha. The weight for y t is alpha, and the weight for y t minus 2 sample is alpha into 1 minus alpha whole square. You can see the weights are steadily decreasing as you are taking old values. If you take very old value, means the weight is very less. So that means those old values are given very less importance. So that is what is happening in the simple exponential smoothing. So where the weights are proportional to exponential function. Here you can see alpha, it ranges from 0 to 1. You can note it down. You can write the same equation in this manner. Alpha yt plus 1 minus alpha into y cap. Okay. This is nothing but again average of yt given t minus 1. So this is the average or predicted value of t plus 1 given t is equal to alpha into yt plus 1 minus alpha into yt given t minus 1. So this is a simple representation for this equation. This is the simple representation for this equation. So the only thing you need to understand is the weights are decreased exponentially, and here the hyperparameter is alpha, and its value is in between 0 to 1. Okay, students. Thank you, students.